Okay, guys, it looks like time's up, so let's start. Okay, so first things first, I'm really glad that you came here and decided to see this talk. My name is Grzegorz Piwowarek. I'm from Warsaw in Poland. I work in a software house called Talk, and besides being a software developer, I used to be a professional Yoyo player and part-time musician. But enough small talk, we don't have much time, so let's get straight to the essence. Okay, so Java 8 was a very special release because it brought to the Java ecosystem some ideas from functional programming, like lambdas, optionals, streams, and so on. And actually, some people started calling this release functional. But it was not that much functional after all, because people started noticing that all this functionness of new Java release is basically optional streams, future, lambdas, and not that much after all. So basically, after people were very, very excited at the beginning, the release was heavily anticipated, but it turned out after some time that it's not that nice. So people started making memes and stuff that functional programming in Java is basically pretty much like this, and started discovering other issues with Java 8. So at the beginning, people started noticing that there are only basically three functional control structures, like optional, streams, and future. And other languages, like Scala, they have many more. There was no such concept as memoization introduced to Java. Don't worry if you don't know those terms, we'll get back into this in a minute. There was no partial functions lifting. And still, after so many years, we don't have tuples in Java for some reason. We still need to write them ourselves or use some external libraries. Optional wasn't serializable and iterable, and it caused some problems in different situations. The biggest problem for me actually was that streams and optionals were not actually introduced to APIs, but we all know why it didn't happen, because Java creators are on a holy crusade. They have very noble reasons to be backwards compatible with previous Java releases. But sometimes you need to break stuff to make something better. But so, of course, it couldn't have been avoided. Some people also complain that when it comes to function representation, instead of one function type, we got functions, by functions, predicates, by predicates, unary operators, binary operators, and so on and so on. This was confusing for some people, and also people were kind of disappointed that even the simplest operations like mapping collections needed so much boilerplate, and probably there were more and so much more problems. But before we jump straight into the essence of this talk, let's have a look at this slide. Basically, when we write code in Java, in many cases, the list of params that are declared there, the declared params are not all params that we operate on. So usually, in many cases, we have also our functions, our methods accept the results might depend on some mutable instance state or on some mutable global state, but still, if those states influence the final outcome of a function, they still needed to be considered, of course, inputs. And when it comes to outputs, let's please notice that we are not only returning basically declared return value, but we also have mutable instance state, global state, because obviously if those can influence the outcomes of other functions, well, those are some kind of return outputs that we need to consider. Obviously, we could also change mutable params and throw exceptions that obviously change how methods behave. So in a perfect world, we would like to write functions and write code that accepts params and returns value, and the connection between input and output is very clear, and that it's direct connection, that there are no other stuff that could influence outputs than the input. So basically, this is all done by we need to avoid mutable states are either instance states or global states. And here comes, I want to recall that basically there is a common misconception that some people say that if you have a language, programming language, and if you have lambdas there, somehow it makes it functional. But it couldn't have been further from the truth. So basically, there are many different approaches to defining what functional programming is, but I really like this definition that I found on one blog, that functional programming is about writing pure functions, about removing hidden outputs and inputs, and about minimizing moving parts, so that our code, our methods, just describe the relationship between inputs and outputs in as directly as possible. So before we go further, we need to recall also two very special terms for functional programming, which is immutability. This term is pretty intuitive to understand. It means that when we are creating objects, after creation we can't modify them. This gives us thread safety for free and allows us to avoid many potential problems. For example, when we are putting objects to hash maps, this hash gets calculated and stored inside. But if we modify this object outside of a hash map, suddenly it might lose, and we might lose him. And contains method on a hash map might return false. So when dealing with immutable values, we might avoid many problems like this. The other thing is referential transparency, which could be explained in such a way that if we have the methods or statements, expressions, if we call them with the same sets of params, and regardless of the amount of times, quantity of times we call them, they will always produce the same results. So in such case, if function method is function transparent, we should be able to substitute the call with params with a result is produced, and it should always work. So few tweets. As again, functional programming is by using immutability and avoiding side effects, we essentially just minimize the amounts of moving parts that can break at some point. But also, there's another misconception. Many people say that that functional programming is all about removing mutability and side effects from our world. But obviously, it's not. We can't avoid it all the time. So in functional programming, we are trying to encapsulate everything in such a way that we don't need to directly deal with the problems that mutability and side effects cause. And since we already know that functional programming is not about lambdas, but the very important thing is to be actually able to pass actions some way. Because in functional programming, we are trying to build very small trivial blocks and compose them together. And when we are composing very small, trivial, potentially working blocks together, we end up with something that eventually will probably work. And when we have blocks that might throw exceptions or behave in a very way that's hard to predict, when we compose them together, eventually probably there's a huge chance that this might blow up. So as we know, lambdas is not everything. We can probably program functionally without lambdas if we are able to pass actions some way. But actually, it's very hard to do if we don't have the right tools for the job. So if we have a look actually at Java Collections API, we have many methods like add, remove, clear. And if we look at the values that get returned there, we can observe that the whole Collections API embraces mutability. It encourages us to use mutable structures. And there is a problem, because let's say that we really want to deal with, we decided to try immutability, but we can't do this because one of the basic building blocks of a language is something that embraces mutability. Of course, we had Guava and other stuff, and some immutable views for collections, but still those were just more like half measures. And this is basically where Javaslang comes into play. Javaslang was designed as a set of tools that fill in all those blanks and make functional programming in Java 8 and higher much more easier, okay? So what's Javaslang? Javaslang, this is what you can see there. As you can see, it might be not very readable, especially from guys sitting in far away. So let's break it down. So Javaslang basically consists of like three building blocks. We have a lambda, we have a set of tuples, and a mighty value. When it comes to what's lambda? Lambda is basically the same. It's a set of functional interfaces, quite similar to those that were in Java 8, but those are kind of on steroids. So for example, if you have a look now at the first line, this should look pretty similar for you, because it's pretty much like Java 8. But if you look at the name of the function, you can see this 2 at the end. This number signifies arity of a function. So in Java, you don't need to try to search for a different name for those functions. And here it's very predictable, okay? So if you're looking for a function that accepts 7 parameters, this won't be called, well, I don't really know how to use this word with 7 for 7. But in this case, we are simply looking for function 7, and this is very predictable and easy to use, intuitive. Also, the very big pain when it comes to Java 8 was dealing with checked exceptions. The problem was that in all those functional interfaces, if you looked inside, there was no throws clause in the method that was supposed to mimic and serve as a body of a function. So every time we encountered the check exception, unfortunately, we needed to try and catch this, and usually just either pack it into runtime exception or just swipe it under the carpet. So it was really painful, especially when you were dealing with streams and multiple lines of lambdas. And let's suppose that you wanted to catch only one situation when let's say 1 of 5 lambdas throw an exception. You couldn't do this. You needed to repack all of those exceptions and try to catch them again. It was a hell. So this time, now it's solved. We have like we have a checked function, which is like a brother to a normal function interfaces, and they all support throwing checked exceptions, so it's not a problem anymore. Also, those interfaces can be composed together, just like in Java 8. But additionally, we can perform partial function lifting, we can carry them, and my favorite feature, we can memorize the results. What does it mean? Let's start with lifting. Okay, so in a world of functions, we have something like partial functions. That means this is a set of functions that accept some parameters, but do not always give us a result. And in a Java world, it usually means that some exception is being thrown. So if you look at the first function over there, you have 3 parameters, integer, 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 which means that function accepts 2 integers and returns integer 2. But if you look at the body of a function, you will see that there is some division being performed. So as we all know that if we divide by 0, nothing good will happen. So we can perform lifting on such a function in a very easy way. And just use lift static function or lift instance method. And as you can see, now return type has changed from integer to option of integer, okay? So we'll always get an option, but if some exception was thrown there, we will get an empty option. This way we are getting rid of exceptions, and partial function is being transformed into total function returning optional. Carrying is a concept of representing function of higher arities with a higher function of an arity 1 that instead of accepting many different parameters, it returns another function that accepts 1 parameter less. Okay, and so if we have function of arity 5, we want to carry it. It will be represented as function 5 returning function 4, that function 4 returning function 3, and so on and so on. When we have function in such representation, it's very easy to apply partial application there. So as you can see here, we defined a function called sum that's supposed to sum two integers together, and we are creating a carried version of it. And notice now that function is returning another function. And let's say that we want to apply 2 in the last line. So after applying 2, we actually change the sum function into we fixed one parameter. So instead of summing two integers, we are now basically just summing some integer with 2. Okay, and now here comes my favorite, which is a memoization. So if we are dealing with referential transparent functions, as I told you before, we could substitute the function calls with results with some return values associated with inputs. So if we are dealing with such a functions, why do actually bother with calculating everything every time for the same sets of parameters? We could just cache the results. So let's do this. Let's cache the results. And next time, if we encounter the situation when we are calling the function with the same parameter, let's return it from a cache. Okay? So to create such a function in Javaslang, it's very easy because you just use instance method called memoized, and it's already cached. So as you can see now, let's have a look at this situation. It's actually very nice. It's very easy to show how it works on a very bad examples. So I created a function of math random. It's something that's totally opposite of what should be a referential transparent, because we are expecting now a function to basically return another result every time it's being called. So let's try to memorize it. And this is how you can basically break math random. So now, after the first call, the returned result is cached, and for every future call, it will be returned straight from a cache. Okay, we also got tuples. If you don't know what a tuple is, it's just a simple, nice way of grouping few objects together. So basically, if you have a situation in your code that if you need to group some properties together, and this situation doesn't deserve another object to be created for them, you can use tuples. Obviously, they are immutable, and they support some nice thing. So you can perform mapping by providing two mapping functions there. You can transform there and even convert them to sequence. So as you can see, we are trying to utilize polymorphism as far as possible. Also, the most important thing in Javaslang is sets of values, like option, try, lazy, either, future, validation. What's more, the whole collections API is a value too. And what's very important is that value extends an iterable. So this is like the common denominator between Javaslang and collections API known from Java. This is how we can ensure interoperability in many cases. Also, but now you think, wait, option, try, lazy, either, they extend value and they extend iterable too? Okay, because it makes sense from some point of view. If you think about them, all of them are kind of containers that can hold the value or not. So basically, yeah, we can consider them iterables that can hold at most one value. It can be really useful in some cases. So let's have a look at some details. Option, as you all probably know from Java 8, it allows us to operate on values that can be nullable in a very nice and concise way. So obviously here it will be, additionally it will be serializable and iterable. So as you can see, we are putting into an option something that might be nullable. Then we are declaratively providing it with two functions that need to be performed on the underlying value, and then in the last line defining a default value that should be returned in a case nothing is inside. Okay, and here's a very common problem, because if you encountered a situation where you had a stream of optionals in Java 8, you needed to do some kind of workaround. If you wanted to filter only like present values, you needed to at first filter using optional is present predicate, and then map and extract this value from an optional, and then of course another time collect to list. And it doesn't seem like it's. I always have a feeling that it could have been done much easier. But now in Javaslang, if option is iterable, you can simply use a flat map. And in such case, after performing a simple flat map, after one-liner, we end up with values that were held inside optionals. And those that were optionals were empty were omitted, as simple as it is. Also, try, another nice tool. It's kind of similar to an optional, but this time we are dealing with values that might produce an exception. So we put something inside a try, perform some operations declaratively, and in the last line, when we can handle the situation if some exception has been thrown. So in this case, as you can see, we can just specify that get or else unknown, and in this case, it means that if some exception was thrown on the way, the unknown string will be returned. Also, the very nice thing, Java as a language doesn't support lazy initialization. Sometimes we needed to implement it ourselves. In Javaslang, you can also find this one. The API is pretty much similar as option, try, and other tools. So you can pretty much usually just specify it using method of and putting there a result of some, let's say, very long-lasting computation. Then specify declaratively what should be done on this object, this value that will be calculated eventually, but everything will be calculated when we call .get method. Also, Javaslang utilizes a set of functional data structures. Unfortunately, we don't have much time to talk about this, but there is a very good talk about this concept it's the whole conference talk by Oleg Shelayev. It was presented on Java 1 and Devoxx Poland and probably a few other Devoxes too. So definitely you need to check it out. But what you need to know is that functional data structures are immutable, persistent with referential transparent methods. What does it mean to be persistent in terms of data structures? It means that the internal structure of a data structure allows us to somehow save and reuse other data structures before modifications. So if you have some list, if we modify it, if you want to deal with immutability, we would need to create copies all over again, and we would be just end up with too many copies. So when we have persistency, we are somehow trying to reuse the previous versions of some data structure. So for example, if you have a list, it's organized in such a way that you hold the reference to its tail and to a new head element, and it's constructed in such a recursive way. But once again, Oleg Shelayev's talk is very good, and you should definitely check it out. And now let's go to sequence from Javaslang. Unfortunately, once again, we don't have much time to go through the whole tree here. But basically, as you can notice, all those structures like array, vector, stack, queue, they obviously persist. They are functional data structures. You probably know how they work. But there's also one that kind of doesn't fit here from the Java 8 point of view, because you have a stream there. Stream in Java 8 is basically a very fancy form of an iterator. But here it's a full, normal, 100% collection that we can use. Okay, what's also very interesting, that if we traverse this type hierarchy up, we'll see at some point that that sequence extends function. Well, very interesting. We are again trying to squeeze as much as possible from polymorphism. Because if you think about this for a while, you will realize that when we have in sequences, we have kind of connections there between indexes and values. We form some connection between integer as an index as in values. So why not treat it as a function? In some cases, it might be really useful. If you wanted to map some other collections according to values held in another collection in a map, it's very handy to sometimes just provide the collection as a mapping function instead of just trying to deal with this manually. Okay, and the best thing over there, when I was playing with Stream API from Java 8, at the beginning, I felt kind of overwhelmed because we had kind of too many. I felt that there are too many methods in the API. But at some point, I noticed that there are some lags. And as you can see, this is a screenshot from IntelliJ IDEA. And you can see that the amount of methods is pretty much overwhelming, and you can find pretty much anything you really want for every context. So all those methods that you missed in Java 8 Stream API, all of this is here, and it's really good. Okay, so you can even create nice stuff like this and impress your colleagues at work. But now the nicest thing in Javaslang is that the guys managed somehow to implement pattern matching in Java, which is a feature known from other functional languages. Pattern matching is like a switch case on steroids. And in this case, as you can see, it's a very nice and concise way of performing actions when you have many different conditions that could be met. So as you can see, you can write just match off, and then specify different cases and results that should be returned in case one of those is matched. Obviously, what's really nice is that you are not limited to predicates only. You can basically use match the whole values at the same time using this nice $sign. What's really interesting that you can match, you don't need to match the whole objects. You can match objects partially. In this case, you need to use special patterns created using special annotations from one of the Javaslang modules, and you can perform matching only on certain elements inside. Okay, so you can, for example, match local date, all local dates 2016, and let's say only grab all that are in 2016, but match and hold and perform some operations on remaining fields. What's really nice that you can also use some perform matching using types. And as you can see here, we are matching an optional and trying to match situation when there's something is inside and when it's not. Also, don't worry, in Javaslang there is a predicates class which comes with a set of predefined predicates for every possible situation. So there is no need of defining them all the time. Very simple cases like predicates is in, or instance of. It's already out of the box. Also, what's really nice is that I want to remind you that you don't need to use pattern matching standalone. Okay. It blends really nice with the APIs of try and all try options and other tools in Javaslang. So we are getting straight to the end, and I was just talking about Javaslang core, but we have there are many more that are worth exploring. We have a Javaslang module for JSONs. There is some circuit breaker and much more very interesting stuff. And generally, that's all. So thank you very much. I have a lot of stickers for you, so don't hesitate and come here. And I hope you like it, and I hope that I sparked some ideas for you to go explore Javaslang and try using it on a daily basis. Thank you very much.